Hi, I'm Daz. On the bench today is a Cossor 499 from around 1949. This one is a battery set. It was also available in a mains version as well, so you could have battery or mains. What attracted me to this set was it's got Bakelite sides and metal front. It's got interesting controls on the side. This one's sort of dual, or even this side is, sorry. You've got wave change and tuning on one side, and this side is off on volume. There's metal on the back as well. Underneath you can see a couple of thumb wheel releases, and there's a little socket here on the left which is an external aerial socket. So we'll get the back off and have a look inside. So here's the instructions, which are sort of in the back here, in the back cover. Apparently it takes two 45 volt batteries in series, which is different, to make up the 90 volts HT, and a 1.5 volt battery of course for the low tension. This is a battery valve radio. Here's the radio with the back off. It looks like there was some clips here to hold the valves in there missing. Here's the output transformer, tuning capacitor, wave change switch there built on with the tuning, and the cord looks good. Permanent magnet speaker, well, it's a battery radio. Leads look like they need some work doing on them. Now apparently to get the front off, so you can work on the radio, there is a couple of nuts and bolts here. Also there's self-tappers, and it's in this hole here I believe, and I think I can see one. I'll put my head right in the way now. Down this little hole here, so there's a self-tapper there. So we'll get the front off, and then also going to have to remove the speaker to see the see what components we've got. No doubt loads of waxies. Here's the radio with the front cover removed. See the speaker, looks like an aerial coil, and various waxies looking at me there, so that's quite a bit of work there required. Tuning cord doesn't look too bad, but there we go. The one thing that puzzled me about this set is where's the aerial with a metal case, and just down here round 4 lugs, which is rather difficult to see, is a wire aerial wrapped round on this side of the radio, and there's a aerial trimmer down here as well next to the aerial socket. So there we go. A close up just showing the aerial on the side of the case, and you can just see it there, that line there. Before I remove the loudspeaker, I'm just going to check. That sounds good. There's a nice distinct crackle there. I'm just going to switch up range. It's about 450 ohm on the output transformer. But I had to use the lower range in order to get a click out the loudspeaker. And yes, it says that the output transformer is about 450. So, yep, that's quite good. So we'll proceed. Although they very kindly provide a nice aperture here to get at the screw, there's a bit of a problem there, because all my dumpy screwdrivers, the blade's too thick. So I'm going to have to use this and probably a pair of pliers to undo that bolt. Nice sized loudspeaker, good 6 inches, and it's dated 22nd of November 1949. It's about a good 6 inches, this speaker, but bear in mind this radio only has a couple of 100 milliwatts output or so, so a big speaker does help to make it go louder. Looking at the inside of this, and the screwdriver sticks to the magnet, looking inside the set, what's just made me curse is looking at a lot of the capacitors and valve holders are right underneath the tuning scale. that's the right pain in the neck, so it may mean removing the tuning scale in order to work on it. But looking at these 4 screws here, I wonder if I just take the scale off and I'll have access. So with the scale removed, we've got a bit better access now, but still be careful not to go through the cord, I guess. I'm going to just measure some more of the wound components and just check there's no obvious problems there. So the resistances are listed in the trader sheet, which is number 964 in this case. So I'm just going to go through them. About 8 ohms is about right. 13, that's about right. 18, seems a little high, that one. Nevertheless, there's continuity there. Come on, make contact. There we go. That's 17 again, so they're a little bit higher than it says, but hopefully that doesn't indicate a problem. Some other interesting things I've noted is there's a little gap here, and there's the grub screw for the wave change switch. Some other little features I noticed is both the detector and the output valve are mounted on rubber mounts to help prevent microphonics. So that's something interesting, these 2 valve holders. So yeah, I've not often seen that. Another thing I've got to look into is these low value capacitors. They're covered in wax, but I don't think they're paper, so I'm not quite sure if they're going to be leaky or not, so I might have to give them a test. Another bizarre thing that I've discovered, as you can see, I've got the volume control up here, and if I now turn the set supposedly off, the switch is now on. So it's the first time I've seen a reverse switch. This is a bit bizarre. Caused a bit of scratching of my head. But yeah, the on-off switch is reversed. How bizarre. Well, here's the pot in 2 pieces. See, there's a little piece of metal there that knocks this switch into position. Probably not the best way to operate it, but my goodness, that's stiff. So it's the usual spring mechanism, so I don't really fancy taking that apart, but I might have to. Well, I'd rather not take the whole thing apart, but I've re-lubricated the switch part, and I've sprayed some cleaner in here, and it seems much easier now, so we'll reassemble it and see if it works the right way round. Yep, that seems a little bit more satisfactory. It's on when it's on and off when it's off. So just to prove that there isn't a problem with these capacitors, let's give it 100 volts. Yeah, no problem at all. So these ones are obviously okay. Let's give one of the paper ones a zap. Yeah, about 100k. That's not good. With the high value resistances in this battery radio, that really would cause havoc. Okay, so the pot's back in and it's working correctly. When you take something apart like this, always check that the LT and HT haven't got swapped, because if you put HT into the valve filaments, they're not going to last very long. Even if you've got a current limit, there might be enough charge in a capacitor to blow them, so do check that. Yeah, so I'm quite pleased now that that's working. Getting close to power up, although one interesting thing I've noticed is that the valves in the unit are a more modern substitute. So someone's obviously been at this and did a bit of a valve change. Well, I'm just setting up here to apply HT for the first time. and I've noticed a problem. I've got the low tension on and we're only showing about 200 milliamps now. There is 4 valves in here, 3 of them are 50 milliamp filament and the output one is 100, so we've obviously got one valve with a dodgy filament, or there's a problem with the valve holder. But I happen to know that if I remove this one, current doesn't change, so I know it's this valve. So if I remove this one and pop this in, because there's no HT, so it's quite safe to do this, and the filaments are in the same place, so I pop it into here, or at least I try to on camera. Yeah, the current's gone back up to about 200 milliamps again, so this valve has got an open circuit filament, so I'm going to have to find a replacement valve. This is a 1T4, but it's also marked DF91, which is an equivalent. So I better put the valve back where it came from so I don't get muddled, but so that's stopped me from testing the radio. Right, I found a spare valve. And the current hasn't gone up either. That's strange. So another one that's got an open circuit filament. That's very unfortunate indeed. Oh well, oops, I'll try another one. Not sure if that's very new either. Ah, that's better. Current limit's come on. Ah, 260 milliamps, so that's good. So I'm now ready to start bringing the HT up. Alright, I'm going to wind the HT up. Oh, that's good news. 50 volts. Current. It's a bit intermittent, I think, on here. So it's a 4 milliamps at 50 volts, that's good. Keep winding up. Oh yes. That's very promising. Right, there we go. About 11 milliamps, that sounds good to me. Oh yes. Very good. Yes, that's looking very promising. I'm just preparing to set up the radio. There's the IFs to adjust, and you go from the detector backwards with this one. Also, you feed in the signal via the capacitor, which is interesting, which is of course connected to the grid. There's no adjustment at the bottom end because this has got a loop aerial. There is a local oscillator adjustment for the top. There's an adjustment here for long wave, and at the bottom here where the aerial socket is, there's an adjustment for medium wave, and that's set up by coupling a aerial to it. So I'm going to use one of these old hi-fi medium wave loops to do that. Also, interestingly enough, I'm going to go right in front of the camera now. When I reattach the scale, because you've got to have the scale off to get at the IF adjusters at the bottom, but there's two scales. That's obviously an updated scale, and it's got BBC European on it and a few other things, but I think I might put the original one back because it looks so much better, doesn't it, than the paper label, but we'll see. A surprisingly large signal is needed when you're injecting into the capacitor. I'm just going to use the scope to look at the speaker terminals and then twig up the IF that way. Rather conveniently, there is a little mark on the scale for setting the local oscillator, because I thought, where do you find 206 metres on here? Because the scale's quite broad. There we go. The last adjustment, which is the medium wave a trimmer, calls for having the front and back on. As I haven't sorted out any batteries or anything, I think I'm going to have to leave that one until I've actually got batteries in and assembled it, but at least the trimmer is actually accessible from the bottom of the case, so that isn't so much of a big thing. But it wasn't that far out. The long wave was a little bit out. I don't know how well this performs on a long wave, but it's not too bad because it's an actual loaded, the aerial is actually loaded for long wave, so there isn't actually a frame aerial for long wave. It uses just part of the medium wave aerial. I thought it'd be useful just to talk a bit about how the battery valve radio works in comparison with a mains valve radio. I think we're all familiar with a circuit similar to this, where we've got a resistor in the cathode and this provides the negative bias that's needed for the grid in order to get it into the right operating conditions. These mains valves have a cathode that's heated by filament, and the filament is insulated. Has some advantages because it means you can have series string filaments on the mains, and it also means you can run this filament off AC without inducing too much hum. In the case of the battery valve radio, it's a little bit different. It has a filament which is actually the cathode, so we've got no separate cathode connection. So in this case we've got a little bit of trickery going on here. We have a 910 ohm resistor in series with the HT negative, which makes this point here more negative than the actual HT that's used in the set. So that's fed to the grid of the output valve, and that produces a negative bias. So that's how it's done. It also means that it would be very sensitive to any noise on this connection here, because it is actually connected to the grid of the output valve. Also, an interesting note is that the radio I'm working on, it came in a mains variation, and the three previous valves at in the first part of the set do actually run off 50 milliamps, but this output valve actually has two filaments, and if you think about it, it's an output valve. It needs to generate a lot of current, so you need more electrons, so that's why it's got two filaments. And they're connected in parallel in the case to run off 1.5 volts. But in the other set, there has to be multiple switches to be able to switch those filaments all into series. So a lot of switching, and they run on 7.5 volts. It's interesting to note that some of the later sets actually use a 7.5 volt LT battery, so that got rid of having to have all the switching to switch the filaments and make them actually work at 7.5 volts. And of course the other important thing to note is that the cathodes, these filament cathodes must be run off DC. If you attempt to run them on AC, you're going to get a lot of hum. So these battery main sets also have to provide quite a bit of smoothing on the filament supply as well. So getting them in series for 7.5 volt 50 milliamp operation is a definite advantage, because if they're all in parallel, you'd be dropping a lot of current for a drop-in resistor in a case of a set that doesn't have a transformer. A very tricky shot, but you can see the filaments there in the top of this other battery valve I have. This one's a DL96, which is a later valve which has a two lots of 25 milliamp filaments, but yeah, I think that shows up okay. Sorry about the wobble, but there's the filament. Here we have an indirectly heated valve, and you can see the cathode connection to the little tube, and there you can see the filaments sticking out. Very difficult, tricky shot to do holding by hand, but I think you can clearly see the cathode connection to the tube and the two white filaments sticking out there. With an older radio like this, sometimes you need a little bit of help, and these tuned aerials are quite useful for helping these along. There you go, so that certainly does help it along a bit, doesn't it? Okay, so I've changed the leads, and I've connected up my inverter and 1.5 volt low tension battery, some DIN plugs. So I'm going to put the back on now and see if I can trim that trimmer I've tried it with the back off and I definitely wasn't getting a peak. It was just increasing in sensitivity as I unwound the preset, so if it doesn't resonate there may be another problem. Well, we definitely seem to have a peak now. So obviously the metal cabinet has some effect on the inductance on this, on the aerial loop. I do like the way the valves warm up almost instantaneous with these heaters. There is a few scuffs on the front, but I'm not going to worry too much about that. But it is a nice radio, and the metal and the Bakelite really appeals to me, so not a bad radio at all. I think I might keep this one in my collection. I like the little Bakelite handle as well. Anyway, thanks for watching. Hope you found that interesting, and I'll see you soon. Welcome back, some bonus footage. This is my AM medium wave modulator. I cannot find the circuit anywhere, but needless to say it was a circuit I got off the internet. You notice there's a 1 MHz crystal drive in it. There's two valves in here, 6AU6 and a 6BA6. This case and this transformer I picked up from a radio boot sale. It was an exciter for a 2 meter radio. I think it outputted half of 144, 72 megs I think. Here's the underside. Now those of you who are observant will see that I've got a secondary rectifier here and a minus supply. I've modified this circuit. It uses suppressor grid modulation. So basically what it's doing is modulating the suppressor grid. So I've got the suppressor grid held at about 33 volts with this Zener diode here, and then I feed in modulation from the audio valve. Here's the suppressor grid drive here. There's a 1 mega ohm resistor down to ground. There's a what looks like 330k to the minus supply to the suppressor grid, and this cable here, there's a capacitor there to roll off the treble, and there's the coupling from the audio valve. I can't remember this circuit too well, but I've noticed that on the RF output there is feedback diodes, so I think it's got a form of automatic gain control if I remember rightly, which of course improves the sound quality even more. And that gives a really nice modulation. I'm told that suppressor grid modulation is very, very low distortion. So that's basically what's in here, but I just wish I had the circuit to show you. But if I do find some information, I'll put it in the comments. But there we go. Anyway, I thought I'd just show what was inside this. It's a nice long tag strip there with the dropper resistors in. So anyway, that's the end of the little bit of bonus footage. I'll see you soon.